Welcome to What Is It About the Weather, the weekly podcast where we explore all things weather intertwined into our everyday lives. I'm your host, Mark Jelonic, and this week we're going to be talking about solar eclipses and weather. But before we do that, let me just say I hope you've had an enjoyable intertwined weather week. This past week or so wrapped up a little over a week. I think it was actually the weekend before. I'm not 100% sure. Wrapped up, though, the annual collegiate forecasting competition. Now, I've mentioned this on the podcast before, and I've also talked about I really need to do a podcast about the competitive nature of meteorologists. Now, not all of them, but a lot of them are, and why that's actually a good thing for you as somebody who's getting a weather forecast or receiving weather information. There is good in competition, There's benefits to that. But this competition, as I mentioned, and for those that don't know or haven't heard maybe some of the past episodes where I've discussed it or mentioned it, each year you get, somewhere on the order of, let's say, 1,500 to 2,000 people that, either involved in studies specifically related to meteorology or atmospheric science, or even organizations that kind of touch on it. So there's different groups, right? So there's a freshman, sophomore group. There's a junior, senior group. There is a kind of grad student sort of group, and then there's a faculty staff. And as you can imagine, you have them competing in these groups because they're more closely related skill set wise. And there's also this group that's called the Alumni Professional Group, which for the past couple of years, I've been in that group. So previously, as many know, I was associated with Georgia Tech as a research scientist after I got out of grad school there. And until, 2014 is when I was no longer really working there in part of my daily life, I guess. But that changed, of course, this spring with teaching a class. But you got to make a call kind of at the beginning of the year what category you're in, even if your category is going to change. So one of the reasons I've continued to do the competition, so the professional category, we don't get, we're kind of the underground category. We can't really help the team, and you can understand why that is. So there's the individual competition, then there's the team competition. So as individuals, we compete with each other, but we're still not officially recognized. We're even called Category 0, oddly enough. And that, hopefully, it sounds like they're going to change it next year. So at least we're going to compete more formally with one another and can get trophies. And it's a nice, like I said, it's a nice competition. It gives you a chance to gauge how you are compared to your peers, both, within your own school, for instance, how you're doing against classmates and others that you work with, but also nationally. So you can gauge your skill set. And one of the reasons I've continued to do it in the professional arena is it keeps me attached to forecasting. And I wanted to make sure no matter what I've been doing in other jobs, it makes sure that I'm kind of exercising that skill set. Now, for the past 2 years, I've won that category. I wrapped up another win as the competition wrapped up. But I think what was more interesting than that this year for me was the person who won the overall competition. Like I said, you compete against people at your levels, okay? But there's also a national winner. And I've been fortunate enough, Georgia Tech's had 3 of those over the year. 2 of them is Professor Rob Black, and another was James Belanger, who I worked with at Georgia Tech and who is now working at IBM. So they've won the overall competition. That means they were better than any other forecaster over the course of the year for this competition, which is quite a feat. Now, as I said, at the beginning of the year, you got 1,500, 2,000 people involved in this competition, and that dwindles down in terms of how many people are actively involved in the end of the year. But even towards the end of the year, you got 1,000 people that are pretty engaged in this, and I would even say the top few hundred that have a chance of winning something are very involved. So it's no minor accomplishment. It's a pretty big deal to do this. But what stood out this year is it was the first time since this competition's been around, which is a little over 10 years, and it kind of took over from another competition that had been around even longer than that. But this one specifically has been around 10 years. First time a freshman, sophomore category individual won the overall competition, an individual by the name of Carl Schneider, who is studying at Penn State University, did that for the first time ever. And that's really impressive when you think about the knowledge and the skill of all these other groups, which is why it's a bit unusual. It's interesting. I don't know his story. My guess is he's, probably loved weather his entire life, like a lot of people that go into meteorology. But it also gives me a sense that the knowledge of forecasting and this online world in which we live in, so often we talk about the negatives, but I have to imagine that it's been a real positive for him and allowed him to get skill sets and experience and knowledge that he might not have had in a traditional academic environment, so that he could be more competitive at an earlier stage. So congratulations to Carl. That's quite an impressive win. So for the annual champion for the 2016-27 season goes to Carl Schneider of Penn State University, the first freshman-sophomore category individual to do that. All right, so let's jump into the main topic for today. Eclipses. Weather. Now, I want to thank Jack for contributing the first time, was first suggestion about doing this, and I've had a few others. In anybody who listens to podcast or watches the Weather Channel, I don't care what it is, there's a lot of people talking about a big solar eclipse that's going to impact the U.S. this year. And Jack suggested talking about it a little bit and gave some ideas and thoughts, and I've had a few other people bring it up. And specifically, they were, wanting to know about planning to view the eclipse. And we're going to do this in multi-parts. I want to cover it now. At the time I'm recording this, we're about 3 months out here in the U.S. And there's some things to be thinking about now. But as we'll get to, there's a lot that you can't really think about this early. But before we get into the actual eclipse that's taking place this year, I thought we might talk about the question of, does a solar eclipse really change the weather? Now, stories of celestial bodies changing and influencing our weather have been around for ages. Some of them real, some of them not. I mean, the classic one that we think about that's real, is, for instance, the moon changing the tides. I know that's not specifically weather, but impacting the natural environment on the Earth. Okay, so every day the moon and its position have a role on how the tides are, timing, and that sort of thing. So it's not a stretch. And of course, there's also a lot of stretch, when certain things have taken place. And this is not, surprisingly, this holds to eclipses as well as to, it would mean your kingdom would reign supreme or whatever it might be. They're both good and bad omens that have gone with eclipses. And as our science knowledge has continued to grow, we continue to understand that there's a lot that, doesn't really have anything to do with ideas that were thrown around. I always find it interesting that the whole idea of eclipses and some of the first documented, events were almost 1500 BC. And even the ability to predict eclipses has been around a long time. So we had that scientific knowledge, yet at the same time we put all these weird, folklore things around what it actually means when it happens. So if you can predict it, you would think that it's not so mystical. But in any case, that knowledge wasn't necessarily around the globe at the time. But interesting that for a long time, we've understood a lot about eclipses, right? And yet at the same time, our knowledge and our understanding of what that really does to the weather has kind of been incomplete. So let's hit the eclipse basic first before we get how we might think about it from the weather, right? So total solar eclipse, which is what we're talking about this year, happens about every 18 months or so on the Earth. And, really all that's happening is the moon is moving between the sun and the Earth and casting a shadow, right? We get partial eclipses quite often, certainly more often than that. One of the challenges, though, is even though we have these things about every 18 months or so, where it's going to be visible a lot of times could be over water, right? Because, we have tons of it on this planet. So there's a good chance that when we have these solar eclipses that they get missed, these total eclipses. But we also have this nuances in how long they last and everything else has to do with how close or far away the moon is. And actually there's an interesting thing called an annular eclipse, which is when you kind of get this ring of fire effect. So the moon is too far away to completely cast out the sun. And to me, that's kind of an interesting phenomenon. And again, I've heard it mentioned in some other podcasts kind of covering all these things. But the last time we've had this kind of total eclipse going on that I remember in my lifetime, we had a similar one back in I think it was in the 70s when I was younger. And in my location, I don't remember if the track was exactly where we were. We ended up with some cloudy skies, so we didn't get a particularly good view of it that day. And if I recall, that was not uncommon. But on average, any spot on the globe, on average, now we talked about a solar eclipse happening about every 18 months or so, total eclipse. And on average, a spot around the Earth sees one about every 400 years. So, they're really not that common for a given location. Now, the good news in a day and age like today is it's a little easier for us to move around. Different parts of the globe, certainly it's easier than other parts as to, getting from point A to point B and whether you might travel to see an eclipse. But no doubt, compared to even 400 years ago, we're in a drastically different time with, methods of transport that make it a little easier to go eclipse chasing, for lack of better terms. So we know these things. Clearly the sun is being blocked out, and as you can imagine, all right, that's going to have some impact on the weather. And the question is it really localized, or is it something broader in nature? Now, a total solar eclipse, again, we're talking averages here. Usually for a given location, if it's in the swath that is where the shadow is going to be cast, where you can see the full eclipse, it lasts about 2.5 minutes. It can be a little more, a little less. The one in the U.S. this year, I think, peaks at about 2 minutes and 40 seconds, so a little bit longer than 2.5 minutes. Some of the other locations that are in the swath, not so much, okay? So, around that 2.5 minute range. And in theory, I think I read somewhere it can last up to 7.5 minutes. Again, it'll depend on where the position on Earth you are and where the total eclipse is taking place, et cetera, et cetera. Where the moon's position is relative to the sun. But on average, 2.5 minutes-ish. All right. Now, you might think, well, that's not likely to have a big impact. But people have always noted it, and it's not surprising because it also does weird things to animals. So it happens. But you could imagine, right? You're in the sun one day, real bright sun, and you step into the shade, and how drastically different that temperature change might be. Or you're really sunny day, but you got maybe a thunderstorm type of cloud, and you're moving such that all of a sudden you get to where that cloud is, and it blocks out the sun, and you can notice the difference. And even commenting on this, Halley, of famous Halley Comet, when he was observing an eclipse in the early 1700s, made a comment about how it felt damp and how the wind changed when it occurred. And even Clayton, I think it was Helm Clayton, discussing a 1900 era eclipse, proposed the idea, because he knew it was coming, and he took the opportunity to make observations of different people that happened to observe the eclipse. What happened in your area, and made some different hypotheses around the idea of an eclipse-driven cyclone. Now, the idea of temperature changes we get. It's pretty easy, as I just discussed, but what impacts might there be on atmospheric pressure? What impacts might there be on wind changes? And that's really what people have tried to observe. And initially, a lot of the emphasis, and again, this is even with the study of meteorology, people thought about the surface, right? Not necessarily the 3D element or the 3D perspective. And in 2015, there was a eclipse across the UK and Europe, and the Royal Society there even did a special issue on the impacts of that. So again, a good opportunity to study. And as we're getting more of these weather stations, little personal weather stations, different places, a good opportunity to gather data about what the impacts were. And Another good one to think about this. Anybody who's ever been near the coast, whether you traveled vacation there or whether you live near the coast, understands this idea of daytime, nighttime changes and diurnal changes. But it's particularly emphasized in those zones as we watch, a sunrise or a sunset as well, if you're in an area like that. And all of a sudden you feel these drastic temperature changes that can take place, and the wind shifts. And the land sea breeze thing is an idea of that. So again, total eclipse only takes a couple of minutes, but the totality of an eclipse can, as it's going through its cycle, can take a couple of hours. And as you can imagine, this may or may not have an impact. So lots of research been done, lots of theory proposed, lots of scientific thought about why it would behave a certain way. A lot of computer models run, again, with this special journal edition that was done, proposing what could happen. And the real question is, are the impacts really localized, or does it cause some sort of broader scale, as hypothesized, eclipse cyclone? And the long and the short of it is, the data is inconclusive. Now, you've heard me say that before. What's interesting is the theory behind it is valid, and you can understand, and I'm not going to get into all the science too much about it, because I don't want to dwell on this and miss the other, actually viewing the cyclone or viewing the eclipse thing. The theory of could it happen is certainly there. The reality of the impacts, my guess is, the reason you may see differences from eclipse to eclipse and study to study and location to location is what the underlying state is. And this actually has something to do with what we're talking about today, which is you've got an underlying, maybe as regular cyclone was in the vicinity or positioned in such a way, and we get something here where I live that is impacted by positions of high and low pressure in other areas, not specifically where I am, that drive behaviors, near the mountains to my northeast, in driving winds and precipitation behavior. And many of us live in those sort of areas where weather patterns are dictated by, the topography of the region, that sort of thing. So all those things are likely to come into play. And end of day, if I were to take a stab at it, my guess is that this has some sort of impact that in the right conditions can drive a certain behavior or amplify a certain behavior more than you would expect. And at other times that the underlying state is so, set in a certain way that you may just not see these things. But I'm sure there'll be more studies, because it is an interesting topic. I mean, we always like to explore these sort of interesting phenomena that don't happen as often. And, even in the studies, they were talking about how much power generation was reduced for solar and wind power, which is can be bigger in certain parts, right? Particularly wind in the UK region, and how energy demand was increased. And so that's again, we get in this intertwined thing. So more people needed power, maybe because there was no lights. They had to turn lights on, and you can imagine that, right? But on the flip side of it, you could argue the same thing on whether you have a clear day or cloudy day. So interesting stuff. Just know, probably nothing drastic is going to happen, right? End of world's not coming. We know that part. We've been through enough eclipses now. But now the other question, right, which is, how do I plan for viewing the eclipse and taking in weather? And I've heard it said before, and I don't know the source of this phrase. I've heard a few people use it, and I'm sure somebody clever came up with it, that climate, you hear the word climate, and that is really described as the Earth's personality when it comes to the state around. What are the normal temperatures like? How much normal rain do we get? How often do we see clouds? So it's kind of the personality, and weather being more the mood. So in planning for this eclipse, and if you really want to go see it, you're going to need to be thinking about these things. Now, I know some people have already made hotel reservations and they've got their pass lined up compared to where this thing's going. And as I said, though, here in the U.S., there's a lot of places that you can get to and even stay in major cities so that you're not running into, this hotel's on the exact path. Well, I guess if you just want to be in a park where the thing may be, and there are cases of that. There's some great places that would be like awesome vacation spots that are also great from a standpoint of, well, I was going to be there anyways. Those places are going to get probably booked up. But if you really want to chase the eclipse, you don't need to necessarily be in one of those places. However, if you're really wanting to plan a vacation, one, you should have probably already been doing it. But two, you should probably get on that now, which is why we're doing the episode. So you should be thinking about that. You should be thinking about, do I have the right things to visualize the eclipse? What kind of protective glasses do I need? And there's a lot of stuff written on this. And I'll put a few links in the show notes just broadly that are great resources for, NASA's got one about how do you just in protecting your eyes and looking at this thing. Now, when the total eclipse is going on and the sun truly is blocked out, in theory, you can look. But, if you get either side of this thing just by a few seconds here and there, it can be really damaging to your body. So you really should be viewing things through these glasses and whatnot that are specially made. And make sure you get the right ones. But what about the weather? What's it going to do? And there has been a lot already written on this. Again, I'll have some things in the show notes. But as I said, we got this climatology piece and we got this weather piece. I'm going to do another thing when it's really about the weather, probably in early August, maybe late July. I'll do another episode because there are some things we could go on and on about it. But we don't know it, right? I can't tell you what it's going to be doing in Atlanta a few weeks from now, much less a couple of months. But what we can talk is the underlying state and what are the odds. And in some cases with the climatology for a region, that's what we're talking about, right? What are the odds? And there have been there's some websites, and one of them is done in conjunction with a meteorologist who used to work, I believe, for the national organization in Canada. I'm not 100% sure on his background, but I know he's a Canadian meteorologist and has done it for years. But he's also into eclipse viewing. And he's put together some things about clouds and about the cloudy nature of different places along the path. So that's one element of it. Now, we talk about that as things go. August is probably about as good a month as any for us to have eclipse viewing here in the U.S. because it is one of what we would classify as the most, generally speaking, on average, sort of benign months that we have. We're not in severe weather season. We're not at the peak of tropical cyclone season. We're not really in the time of year when fronts are moving through and changing the weather as much. All that said, I was looking at some of the history just last year, the week of the eclipse, there was a major frontal system that pushed through the entire path of this thing, and that's the challenge with the weather. That said, there are areas like where I'm at that are more prone to clouds this time of year. Now, that may not ruin the whole eclipse viewing, but if you got 2 minutes and 40 seconds or just 2.5 minutes to see this thing, you probably, and you're going out of your way, you probably want to increase your odds. So generally speaking, once you get over the Pacific coast and kind of the initial mountain ranges, that range from there across the plains of the U.S. has better odds of no cloud cover. And even some of the areas as you get towards where I am in the southeastern U.S., the odds go up that there's going to be clouds. But the challenge, like in an area like mine, is even though the odds may not go up tremendously, the odds on a completely clear day are much lower. And that's probably the thing to keep in mind. So if you really want to enhance your odds and you really want to be thinking about it now and you really want to plan maybe a vacation maybe you want to go to Yellowstone Park around that time, or the Badlands of South Dakota, or wherever it might be, or somewhere in that region, you could plan a trip and enhance your odds. And again, there'll be a link in the show note about these maps. And he's even gone in, like I said, I think more importantly than just the overall odds are the types of cloud cover you might get during the day. And he's done some nice graphs along those lines. And we've even looked at things like, the Weather Channel had one that kind of took that in, but also took in just the chances of precipitation. Like I said, that's what led me to just looking at last year in the maps and seeing this kind of progressing cold front that in theory could impact anybody. But those are the types of things I think we'll get into as we get closer to the eclipse, which is, all right, I'm a few weeks out. Are there any dominant patterns? Is there a risk even a tropical cyclone? Because I'm here in Georgia, and I may say, hey, I'm interested in doing this, but I'm going to do it somewhere close to home. But looking at that information now would be crazy. However, I might know at that point in time whether what we call it's a subtropical high or the Bermuda high is more inclined to give me, like I saw some in August, September last year, these just completely blue sky days. Is my pattern set up for that? Or is there a tropical cyclone potentially coming in the region that could have days of impacts and it's not even worth my time and that I should look afar? So there's going to be some things that come along as we get closer, kind of in that 1 month range, where we see certain dominant patterns in the flow that maybe you could make an adjustment of, hey, I'm going to do a trip or I'm going to drive a little further away, or am I safe to stay where I am? And then some stuff that we get down in that final day that I'm not going to do, but that you can be thinking about I'm in position A, do I head east or west? And what you don't see in most forecasts, right, is cloud forecast, and it's because it's tricky. But there are places you can do it, and there are models that look at this stuff, but you'll probably have to refine your behavior right up until the final day as to which direction you want to head to maximize your chances of seeing the total eclipse. But for now, maybe think about what are the odds. Because that's all you can really do is play the odds. So if you really want to plan this far in advance, you can look at some of these locations and increase your chances of getting to a spot. And hopefully the news is if you pick one of those places, especially the ones that are in the interior U.S., you're not likely to see these either Pacific or, Gulf of Mexico type storms impact things. So it's unlikely that you will end up in a situation where you're going to have days of clouds in those regions. But all that said, it's still a bit of a guess. So look at some of these resources that I'm going to put in the show notes. If you really want to plan this far out, to start gauging. But like I said, we'll come back to this topic later July, early August, and start honing in on the things that you as an individual can be thinking about as you're planning your final week beforehand, your final couple of days, and the day of, so that you're maximizing your chance, if this is something you really want to do, of getting that eclipse. And just remember, in all that, right, that, you might need a windbreaker if it's a sunny day, or a little warmer stuff for when the eclipse actually occurs. But, that may only take a couple minutes of really heavy temperature drop that you experience. All right. Interesting tidbit, of course, as I was looking through all this and thinking about how clouds, in and of themselves can decrease a temperature, I found an interesting statistic that the fastest or the largest temperature change, and who decides on these records? Spearfish, South Dakota, world record. Biggest change in temperature in 2 minutes. 49 degrees Fahrenheit, 27 degrees Celsius, 2 minutes. Let's imagine that. That is a temperature change. And that is probably much more than what you're going to see from this eclipse. Don't forget, though, in all seriousness, if you're going to do this eclipse, you can get these cheap glasses. I just can't emphasize enough. Don't do anything stupid with these things. The sun can really damage you in a lot of ways, right? And looking at it is one of those ways permanently. So make sure you get the right glasses. Like I said, the NASA link in there, I'll make sure to put a little asterisk in it in the show notes or something. They have a section in there about viewing specifically, and don't just go online and do eclipse glasses. There are a few companies that really focus on it, and they meet a very, very specific viewing. It's like an ISO standard that you need to make sure that's there, because we don't want anybody coming away from this with any sort of damage. All right. Time to let you go. Get on with your weather week. If you got any questions about Ask What Is About the Weather, like I said, sometime in June I'm going to be doing an episode, now that I've been doing this a while, of just, random questions I've gotten. Not so much about episodes, but about, what I've enjoyed, what are the challenges, what I found interesting, what I haven't liked even. So if you have anything, send it along. We're going to be upcoming episodes. We're going to hit on a couple of topics. I've been back in communication with the listener who is totally blind about doing weather information and getting good at weather information different ways. And I'm not going to probably do just the visually impaired, but just those that deal with impairments in general, and how we ought to be thinking about how we communicate this. And, that it's not just weather information, it's any sort of important information. But, of course, in our case, we'll probably focus in on weather information, and not only just making severe weather accessible, but just weather in general, weather data in general accessible to all parties. Of course, we'll have a Did Weather Change History episode coming up here, I think, before the end of the month as well. All right. You know how to get hold of us, right, by now? I hope. And you know the drill. RSVP, rate, share, validate, and pledge. Rate, go on iTunes, whatever it is. Those sort of things help discoverability. And that gets along to sharing. And sharing is not just telling other people about it. It is sharing your ideas, episodes, thoughts you have. And then we get into validate. Are we doing good things? Are we doing things you wish we did different? And, of course, pledge. Jack, who was the one who sent this episode, was also the one who, made a donation and supports the podcast. So thank you to Jack, amongst others, who are supporting the podcast either through Patreon or through a one-time PayPal donation. And you can learn more about that at whatisitabouttheweather.com/support. Whether you want to send us feedback, whether you want to send us an idea, a question, whatever it might be, whatisitabouttheweather@gmail.com or whatisitabouttheweather.com/contact. Looked either way. So until next time, may you have an enjoyable and an interesting, of course, intertwined weather week. Because as we all know, there's much more to weather than the weather itself.